I'm Geoff Pynn. I teach at Northern Illinois University, and this is an introduction to critical thinking. In this lesson, we're going to talk about three things. First, what is critical thinking? Second, what is an argument? And third, what's the difference between deductive and ampliative arguments? Okay, so what is critical thinking? Well, fundamentally, critical thinking is about making sure that you have good reasons for your beliefs. What does that mean? So suppose that you and your friend are talking about who's going to be at tonight's party. And she says to you quite confidently, Monty won't be at the party. You're not sure whether or not to believe her, so it would be natural for you to follow up by asking, why do you think so? And there are a lot of different things that she might say in response. We're going to talk about three possible answers she could give. First, she might say, I can't stand him and I want to have a good time. Second, she might say, well, he's really shy and he rarely goes to parties. And third, she might say, he's in Beijing and it's impossible to get here from Beijing in an afternoon. The first response that she gives you does not give you a good reason to believe that Monty won't be at the party. The second reason, though, is a good reason to believe that Monty won't be at the party. If he's really shy and rarely goes to parties, then it's probable that he won't be at tonight's party. Similarly, the third reason also gives you a good reason to believe that Monty won't be at the party. If he's in Beijing and it's impossible to get here from Beijing in an afternoon, then it's guaranteed that he won't be at the party. And when you notice things like that, when you distinguish between good and bad reasons for believing something, you're exercising your critical thinking skills. So critical thinking is making sure we have good reasons for our beliefs, and so one of the essential skills that you learn when you're studying critical thinking is how to distinguish good reasons for believing something from bad reasons for believing something. Now, it's worth saying something about how I'm using the term good here. I'm not using it to indicate anything having to do with morality or ethics. So it's not morally right or morally good to believe something on the basis of good reasons. Similarly, it's not morally wrong or evil or wicked to believe something on the basis of a bad reason. Rather here, what it is to say that a reason is good is closely tied to the notion of truth. So a good reason for a belief is one that makes it probable. That is, it's one that makes the belief likely to be true. The very best reasons for a belief make it certain. They guarantee it. So why does this matter? Well, the reason that critical thinking is important is because since we're rational, we want our beliefs to be true. Rational people want to have true beliefs, and they want not to have false beliefs. And the best way to be rational in this way is to form beliefs only when you find good reasons for them. Okay, that leads us to our second question, what is an argument? Well, an argument is a set of statements that together comprise a reason for a further statement. So, for example, we can consider one of your friend's responses before as an argument. She's given you two statements, Monty's really shy and Monty rarely goes to parties, which together comprise a reason for believing that Monty won't be at the party. The statements that are the reason we call the argument's premises. So Monty's really shy is premise 1, Monty rarely goes to parties is premise 2. And the statement that those premises give you reason to believe we call the argument's conclusion. A good argument is one in which the premises give you a good reason for the conclusion. That is, the premises make the conclusion likely to be true. In that case, we say that the argument supports the conclusion. Good arguments support their conclusions, and bad arguments don't support their conclusions. So a key part of critical thinking is learning to evaluate arguments to determine whether or not they're good or bad. That is, whether or not their premises support their conclusions. The red argument is the first response that she gave. Two premises, I can't stand Monty and I want to have a good time. And the conclusion is Monty won't be at the party. And the third argument, which we'll put in purple, consisted also of two premises. Monty's in Beijing and he can't get from Beijing to the party in time, so he won't be at the party. Now, as I indicated before, the first argument is not good, while the purple argument is good. And here I can explain a little bit more about why. If you consider what the red argument's premises say, that your friend can't stand Monty and she wants to have a good time, and think about their relationship to the conclusion of the argument, you'll see that those statements don't make that conclusion any more likely to be true. The fact that your friend can't stand Monty and wants to have a good time doesn't do anything to make it more likely that Monty won't be there. It's simply unrelated to the conclusion. In the purple argument, though, the premises, if they're true, they guarantee that the conclusion is true. So they make it very probable. The truth of the premises guarantees the truth of the conclusion, and so in the purple argument, the premises do support the conclusion. Now, it's worth pointing out that the red argument, though it's bad as it stands, could be made a good argument with the addition of some background premise. So, for example, if you found out that your friend was the person who decided who was going to be invited to the party, then the fact that she can't stand Monty and wants to have a good time would give you a good reason to believe that Monty won't be at the party, because it would give you reason to believe that she didn't invite him. But as it stands, the argument is not good. Those two premises considered in themselves give you no reason to believe that Monty won't be at the party. Okay, our last topic is to distinguish two different types of arguments. So I'm going to put up here on the left the orange argument, which is the second response that your friend gave. Monty's really shy and he rarely goes to parties. On the right, we'll put the purple argument. Monty's in Beijing and he can't get from Beijing to the party in time. Both of them have the same conclusion. Monty won't be at the party. Now, as I said before, both of these are good arguments. They both do give you reason to believe the conclusion, i.e. both of them have premises which support the conclusion. But there's an important difference between the two arguments that I want to point out. If you consider the purple argument and think about what those premises say, you'll notice that if those premises are true, if Monty's in Beijing and can't get from Beijing to the party in time, then it must be true that Monty won't be at the party. Those premises guarantee the conclusion. In such an argument, where the premises guarantee the truth of the conclusion, we call the argument deductive. In a deductive argument, given the premises, the conclusion must be true. Just thinking about the information in the premises in a deductive argument gives you all you need to deduce the conclusion. If you look at the orange argument, though, you'll notice that that's not the case. In the orange argument, even if those premises are true, the conclusion might still be false. Even given that Monty's really shy and rarely goes to parties, it's still possible that he'll get over his shyness and suspend his policy of rarely going to parties and unexpectedly show up. It's unlikely, but it's possible. So the truth of the premises in the orange argument does not guarantee the truth of the conclusion. Arguments like this we call ampliative. In an ampliative argument, the truth of the premises makes the conclusion probable, but doesn't guarantee it. Now, as I said, both of the arguments are good. Ampliative arguments can often be very good arguments. They're just not deductive. The premises don't guarantee the truth of the conclusion. Now, when you're evaluating an argument, it can be important to know whether or not the argument is supposed to be deductive or supposed to be merely ampliative. If an argument is supposed to be deductive, but careful consideration of the argument reveals that in fact the premises don't guarantee the truth of the conclusion could be false even though the premises are true, that's often a good reason to reject the argument as a bad argument. Whereas in an ampliative argument, to notice that the truth of the premises doesn't guarantee the truth of the conclusion is simply to notice that it's an ampliative argument. If you were to object to the orange argument by pointing out that still the conclusion could be false, you'd really be missing the point. In an ampliative argument, it's taken for granted that the conclusion is not guaranteed by the premises. Rather, what an ampliative argument is doing is giving you reasons to think that the conclusion is probable. So knowing what type of argument an argument is essential to knowing which tools to use to evaluate whether or not it's a good argument. And we'll talk quite a bit more about different tools for evaluating both ampliative and deductive arguments in future lessons. Okay, so summing up this lesson, critical thinking is making sure that we have good reasons for our beliefs, where we understand a good reason as one that makes the belief probable or likely to be true. An argument is a set of statements, which we call premises, that together comprise a reason for another statement, which we call the argument's conclusion. And in a good argument, the premises support their conclusions. That is, the premises give you a good reason for believing the conclusion because they make it probable. A deductive argument is one where the conclusion is guaranteed by the premises. If the premises are true, then the conclusion must be true. An ampliative argument is one where the premises don't guarantee the conclusion, but they do make it probable, so they can still provide you with good reason for believing the conclusion. Okay, so that ends this introductory lesson. Hi, I'm Geoff Pynn, and I teach philosophy at Northern Illinois University. In my earlier Introduction to Critical Thinking video, I described the difference between deductive arguments and ampliative arguments.
In the next few videos, I'll talk a bit more about each type of argument. Let's start with deductive arguments.
An argument is a set of statements, called its premises, that are meant to give you a reason to believe some further statement, called the argument's conclusion. In some arguments, the premises are meant to guarantee that the conclusion is true. Arguments like this are called deductive arguments. A good deductive argument can give you a very good reason for believing its conclusion. After all, it guarantees that its conclusion is true. But not all deductive arguments are good, and so there are several things to think about when deciding whether to believe the conclusion of a deductive argument. A good deductive argument really does guarantee its conclusion. Part of what this means is that it's impossible for the premises to be true, while the conclusion is false. When this is the case, we say that the argument is valid. Now, this is a special technical use of the word valid. In ordinary life, we often use this word to mean something like good, cogent, or reasonable. Like, if you're disagreeing with someone about something, and they respond to a claim you make by saying something that seems pretty reasonable to you, you might say, well, I guess you have a valid point. Though that's what the word often means in ordinary life, it's not what the word means here. When philosophers say that an argument is valid, they always mean this very specific thing, that if the premises are true, the conclusion must also be true. There are several other Wi-Fi videos that discuss this notion of validity in more detail. To say that an argument is valid is to say something about the relationship between the premises and the conclusion, namely that if the premises are true, the conclusion must also be true. But it's not to say that its premises or conclusion are true. Consider, for example, this argument. Premise 1. Beyoncé was born in Paris. Premise 2. Everybody who was born in Paris loves cheese. Conclusion. Therefore, Beyoncé loves cheese. Those premises are false. Beyoncé was born in Houston, and I'm willing to bet that at least some people born in Paris hate cheese. Still, it's a valid argument. If the premises were true, then the conclusion would have to be true. But because the premises are false, this argument doesn't give you a good reason to believe its conclusion, even though it's valid. Philosophers call a valid argument with true premises sound. Like the word valid, the word sound is a term with various meanings in ordinary life, and it can be used to describe some claim as reasonable or compelling. But when philosophers describe an argument as sound, they always mean this very specific thing, that it's valid, and that its premises are in fact true. Here's a pretty boring sound argument. Premise 1. Beyoncé was born in Houston. Premise 2. Everybody who was born in Houston was born in Texas. Conclusion. Therefore, Beyoncé was born in Texas. For more discussion of the concept of a sound argument, see Aaron Ensel's Wi-Fi video entitled Soundness. So, before deciding whether to believe the conclusion of a deductive argument, you need to determine whether the argument is sound. And this in turn requires determining whether the argument is valid, and whether its premises are true. Well, how do you tell whether an argument is valid? Sometimes it's just obvious, but often it's not so obvious. One way to figure out whether an argument is valid is to see if you can think of a counterexample to it. A counterexample is a case, either real or imaginary, where the argument's premises are true, but the conclusion is false. So, for example, consider this argument. Premise 1. Classical musicians appreciate opera. Premise 2. Beyoncé is a pop star, not a classical musician. Conclusion. Therefore, Beyoncé doesn't appreciate opera. Now suppose that Beyoncé's been listening to opera since she was a little girl, and loves Mozart's Don Giovanni. Well, then she'd appreciate opera. The conclusion would be false, even though the premises would still be true. It would still be true that classical musicians appreciate opera, and that Beyoncé is a pop star, not a classical musician. This counterexample shows that the argument isn't valid, and so that even if the premises are true, the argument doesn't provide you with a reason to believe its conclusion. There are other more formal techniques for figuring out whether an argument is valid, which we'll hopefully be able to discuss in future videos. Now, if you don't know whether the premises of an argument are true, then even if the argument really is sound, it doesn't give you a good reason to believe its conclusion. When you know that an argument is valid, but you don't know whether its premises are true, the argument gives you at best a conditional reason to accept its conclusion. If you learn that its premises are true, then you'll have to accept its conclusion. So how do you tell whether an argument's premises are true? Well, this isn't the kind of thing logic or philosophy can give you much help with. To figure out whether an argument's premises are true, you need to do some research. This is one reason why being a good critical thinker requires more than just logical abilities. It also takes a lot of real-world empirical knowledge.
Unless you know enough to know whether an argument's premises are true, then even if you're a really brilliant logician and know that the argument is valid, it doesn't give you reason to believe its conclusion. The more you know, the better you'll be able to evaluate deductive arguments.
Hi, I'm Geoff Pynn, and I teach philosophy at Northern Illinois University. In this video, I'm going to talk about abductive arguments. Abductive arguments rest on an inference to the best explanation. The simplest way of thinking about this idea is in terms of why questions. Suppose you tell your friend that someone has a crush on him, and his cheeks turn bright red. Why did that happen? What's the explanation? Well, the most natural answer seems to be that it's because he was embarrassed to find out about the crush. That's why his cheeks turned red. This example can be turned into an abductive argument. The premise is, Charlie's cheeks turned red after I told him that Lucy had a crush on him. And the conclusion is, so Charlie was embarrassed to learn about Lucy's crush. Notice that the premise doesn't guarantee that the conclusion is true. Something else might explain it instead. Maybe Charlie was eating a jalapeno and his cheeks turned red because it was so spicy. Or maybe he just got scratched by a cat and he's having an allergic reaction. If you let your imagination rip, you'll be able to think of other possible answers to the question, why did Charlie's cheeks turn red too? Nonetheless, given your background knowledge, C seems like it's the best explanation for P, or at least it's a contender. If it is, then P gives you good reason to believe C. That's how abductive arguments work. We know that some stuff is true, these are the premises, and reason from that to whatever is the best answer to the question, why are these things true? Our knowledge doesn't guarantee that the explanation is correct, but that's okay, because abductive arguments aren't supposed to be deductively valid. Abductive arguments are nonetheless extremely common in all walks of life. It's a very important critical thinking skill to be able to make, spot, and evaluate abductive arguments. Think of how a TV detective solves a crime. Suppose she knows that the murder weapon was found in Smith's trunk. Smith doesn't have an alibi. Smith had a motive. And Smith failed the lie detector test. The best explanation for all this evidence is that Smith's the murderer. And so the detective believes that Smith is the murderer, and for good reason. She passes this argument on to the prosecutor, who uses it to convince the jury to believe its conclusion too. Abduction also plays a crucial role in science. Scientific hypotheses often rest on inferences to the best explanation for some observed data. For example, that's how the planet Neptune was discovered. In the early 1800s, astronomers noticed small discrepancies between the observed orbit of Uranus and the predictions that Newton's theory of motion made about what the orbit should be. The best explanation for these discrepancies was that they were caused by another planet that no one had ever observed. And it turned out that this was correct. There was another planet, which we know as Neptune today. So what makes something a good explanation? Well, there's a lot of debate about this amongst philosophers, but here are two characteristics of good explanations that most generally agree about. First, the more an explanation fits in with everything we already know, the better it tends to be. Consider another possible explanation for the discrepancies between the observed orbit of Uranus and the predictions of Newton's theory. That Newton's theory was wrong. To accept that Newton's theory was wrong would require giving up on lots and lots of other very good explanations, and so wouldn't fit very well with what astronomers already knew. The idea that an unobserved planet was causing the discrepancies fit much better with what they already knew, and so counted as a better explanation. Second, other things being equal, a simpler explanation is better than a complicated one. Here's another possible explanation for Charlie's blush. Maybe he misheard you and thought you said that Penny had a crush on him, and so he's embarrassed to learn about Penny's crush, not Lucy's. This explanation could be right, but it's needlessly complicated. Since the original explanation is simpler, it's preferable to this more complex one. Both fit and simplicity come in degrees, and other factors are also relevant to how good an explanation is. There's no surefire recipe for saying when an explanation is the best one.
One way to challenge an abductive argument is to try to come up with a better explanation of the data than what the argument provides. Another way to challenge an abductive argument is to look for more evidence to add to the premises. Suppose the detective also found out that Smith had a very clever nemesis, who had a motive to commit the murder, and had been planning to frame Smith for a long time. Then Smith's being guilty would no longer clearly be the best explanation for all of the detective's evidence. Now there's another, perhaps equally good contender, namely, that Smith was framed by his nemesis. It's important when relying on an abductive argument to make sure that you get all of the evidence that you can, and then consider all of the evidence before drawing your conclusion. That's because the fact that a conclusion is a good explanation for some evidence doesn't mean that it's a good explanation for all of your evidence. So, summing up, abductive arguments are a kind of ampliative argument. Their premises don't guarantee their conclusions. Abductive arguments involve an inference to the best explanation. Their conclusions are supposed to be the best explanations for their premises. Abductive arguments play a central role in everyday life and scientific inquiry. Good explanations tend to fit with our background knowledge and to be simpler than the alternatives. And finally, you can challenge an abductive argument by coming up with a better explanation for the premises, or by finding additional relevant evidence that isn't well explained by the conclusion.
Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. And in this video, I'm going to discuss validity, an important tool for evaluating deductive arguments. You've probably heard someone say, that's a valid point, or maybe in an argument you've heard a friend say something like, that's valid, but in these everyday uses of the term valid or validity, people often mean to convey something like, that's a good point, or that statement's true. But I won't be talking, in this video at least, about those usages. Instead, I'll be discussing the technical philosophical notion of validity, as in a valid argument. You already know that an argument is a set of statements, and that one or more of these statements is offered in support of some other statements. The statements doing the supporting are called premises, and the statements being supported are called conclusions. Validity, in the sense that I'm talking about it, applies to deductive arguments. So an argument is valid or invalid. Validity then isn't a property of statements or anything of the like. So what exactly is a valid argument then? Well, suppose that you make the following argument, and here I'll use P's to stand for premises, and I'll use a C to stand for the conclusion. P1. All humans are mortal. P2. Iris Murdoch is a human. C. Therefore, Iris Murdoch is mortal. Suppose that I say that your argument is valid. Do I mean to say that your argument is good? Do I mean to say that your conclusion or that all of the premises and conclusion are true? While this might sound like what I'm saying, validity has nothing to do with the truth of the conclusion or with how good the argument is in general. So let's define it. An argument is valid if and only if the truth of its premises guarantees the truth of its conclusion. That is, validity is a property of arguments such that if the premises of the arguments are true, then the conclusion must be true. So it's impossible for a valid argument to have all true premises unless the conclusion is also true. When an argument is valid in this sense, we say that the premises entail the conclusion. So let's back up for a second. An argument is composed of statements. Statements can be true or false, like the statement, this square is orange. Arguments cannot be true or false. They can, however, be valid or invalid, as well as other things. And if an argument is valid, then if its premises are true, its conclusion is true. Notice that I have not said that a valid argument has true or false premises, or a true and false conclusion. I have said something conditional. That is, if the argument is valid, then the truth of its conclusion follows from the truth of its premises. Conversely, if the truth of the premises entails the conclusion, then the argument is valid. Now, this all sounds very abstract, so let's return to some examples. Let's look at our previous example. I have said that the argument about the British philosopher Iris Murdoch is valid. Am I right? Yes. If the premises of the argument are true, then the conclusion must be true in this case. Remember, it doesn't matter if our premises are true or false. Consider, for example, an argument with all false premises in it. P1, all humans are immortal. Premise 2, Iris Murdoch is a human. Conclusion, therefore, Iris Murdoch is immortal. This argument is also valid, just like the first argument. The truth of the premises entails the truth of the conclusion, right? If it is the case that all humans are immortal, and it is the case that Iris Murdoch is one of these humans, then it's necessarily the case that Iris Murdoch is immortal. Let's try an example with premises of which we don't know the truth. P1, all aliens speak English. P2, Spock is an alien. Conclusion, therefore, Spock speaks English. We don't know if there are aliens, let alone ones that can speak at all. We don't know if they speak English. It could be the case, or it couldn't be the case. But this argument, nonetheless, is valid. If premise 1 and 2 are true, then the conclusion must be true. We could even use undefined terms. P1, all sliff are splat. P2, sniff is a sliff. Conclusion, therefore, sniff is a splat. Again, although the truth of the premises is undefined, we have a valid argument. This is just one type of valid argument form, and you can learn about others in upcoming videos. Note now what it means for an argument to be invalid. The truth of the argument's premises does not entail the truth of the conclusion. For instance, P1, all dogs have fur. P2, Claire has a lot of fur. Conclusion, therefore Claire is a dog. Now, it could be the case that all of the premises in this argument are true, but the conclusion false. The truth of this conclusion, in other words, does not follow from the premises, right? Because cats also have a lot of fur. So this is an invalid argument. You may wonder why validity matters at all, if the truth of the premises doesn't matter. This is a good question to ask, and it deserves a long discussion. But the short answer is that validity is used to determine whether or not an argument obeys valid inference rules, the laws of deductive logic. That is, we are ensuring that inferences in the argument are good inferences to make. I'll leave you with one last example and ask you to determine its validity or invalidity. P1, all fruit is a chair. P2, square is a chair. Conclusion, therefore, square is a fruit. What do you think?
My name is Julianne Chung, and I'm a graduate student at Yale University. Today I am going to talk about truth and validity. There are many different good qualities that arguments can have. For example, they can be clear, they can be interesting, they can be persuasive, and so on. In this video, however, we are going to discuss just two good qualities that arguments can have that are particularly important for determining whether we should accept their conclusions. The first is this: the premises of an argument may be true. That is, they may be in agreement with the facts. In philosophy, truth and falsity are held to be properties of statements, but not arguments. Second, an argument may be valid. An argument is valid when its conclusion follows logically from its premises. In other words, an argument is valid just in case the truth of its premises guarantees the truth of its conclusion. In philosophy, validity and invalidity are held to be properties of arguments, but not statements. To see the difference between these properties, it will be helpful to look at some examples, all of which involve my good friend Julia's dog, Split. This is an example of an argument that has true premises and is valid. Premise 1. All Australian Shepherds are dogs. Premise 2. Split is an Australian Shepherd. Conclusion. Therefore, Split is a dog. In this argument, not only are the premises true, but the conclusion follows logically from them. Next is an example of an argument that has true premises, but is not valid. Premise 1. All dogs are animals. Premise 2. All cats are animals. Conclusion. Therefore, all cats are dogs. Here, the premises are obviously true, but the conclusion does not follow logically from them. Of course, this argument is clearly unacceptable because its conclusion is obviously false. However, sometimes arguments can have true premises as well as true conclusions, but still be invalid because the conclusions do not follow logically from them. Here is an example of such a case. Premise 1. All dogs are animals. Premise 2. All Australian Shepherds are animals. Conclusion. Therefore, all Australian Shepherds are dogs. Because of this, it is important that we are careful to ensure that the conclusion really does follow from the premises under consideration when we are evaluating an argument. We are now going to look at an argument with at least one false premise that is valid. Premise 1. You can't teach an old dog new tricks. Premise 2. Split is an old dog. Conclusion. Therefore, you can't teach Split new tricks. Here the first premise is false, but the reasoning is valid because the conclusion follows logically from the premises. Notice too that just as in the last example, the conclusion of this argument may happen to be true, although the argument does not establish that it is. All right, just one more example. This argument has at least one false premise and is invalid. Premise 1. I like Split. Premise 2. Training dogs is easy. Conclusion. Therefore, I'll win a lot of awards for teaching Split how to roll over. In this example, not only is premise 2 false, but the conclusion does not follow logically from the premises. You have probably already noticed that truth and falsity, as well as validity and invalidity, can appear in various combinations in an argument, giving rise to 4 possibilities. Let's take a moment to review them together. Possibility 1. We may have our facts right, our premises are true, and we may use them properly. Our reasoning is valid. Possibility 2. We may have our facts right, our premises are true, and we may use them improperly. Our reasoning is invalid. Possibility 3. We may have our facts wrong, some of our premises are false, and we may use them properly. Our reasoning is valid. And finally, possibility 4. We may have our facts wrong, some of our premises are false, and we may use them improperly. Our reasoning is invalid. When we are evaluating an argument, we should only accept its conclusions if the first possibility obtains. Philosophers call such arguments sound arguments. Because of this, you might be wondering why we should be at all interested in arguments that are valid, but whose premises are false. One answer is that we are often not in a position to know whether our premises are true. But being able to validly infer the conclusions that would follow from such premises, if they were true, sometimes enables us to judge whether they are true. This is because validly inferring a conclusion that we know to be false from a given set of premises will tell us that one of our premises must be false too. After all, a false conclusion cannot validly be deduced from true premises. Consider the following example. Say that John calls his boss at work one day and tells her that he is in bed with a terrible case of the flu. His boss, it seems, could use that information to construct the following argument. Premise 1. John is in bed with a terrible case of the flu. Premise 2. If John is in bed with a terrible case of the flu, then he is not bowling. Conclusion. Therefore, John is not bowling. This argument is valid. Its conclusion follows logically from its premises. So, if John's boss were to see him bowling, what could she conclude? Premise 2 seems untouched by this bit of evidence. Premise 1, however, is in danger. She could conclude that John is not in bed with a terrible case of the flu. It seems he lied. This is, of course, just a very simple example. That said, hopefully it suffices to show that we often use reasoning like this to figure out whether claims are true or false. Thus, it is indeed often very useful for us to know whether an argument is valid, even if we don't know whether its premises are true. For more information about truth, validity, and soundness, I highly recommend checking out Paul's video on validity and Aaron's video on soundness.
Hi, I'm Aaron Ansell. I'm a graduate student at Duke University, and in this video, I'm going to tell you about soundness, an important notion that philosophers use to evaluate arguments. Let's start by looking back at validity. You should already know what a valid argument is. If you don't, I encourage you to watch the video on validity before watching the rest of this video. As you learned in the video on validity, an argument is valid if it is impossible for all of the premises to be true, while its conclusion is false. For example, the following is a valid argument. Premise 1. All cats are purple. Premise 2. Everything that is purple is a person. Conclusion. Therefore, all cats are people. This argument is valid because it is impossible for the premises to be true while the conclusion is false. If all cats were people, and all purple things were people, then all cats would be people. Of course, not all cats are purple, and not all purple things are people. So even though this argument is valid, it's not really informative. It does not establish the truth of its conclusion, since the premises are obviously false. Since the goal of an argument is usually to show that some conclusion is true, we usually want arguments that are more than just valid. This is where the notion of soundness comes in. Soundness is a technical notion in philosophy. What philosophers mean by sound is a bit different than what people ordinarily mean when they say things like, "That was sound advice," or "She demonstrated sound judgment in making that decision." In philosophy, soundness, like validity, applies only to deductive arguments. In order to be sound, an argument must meet two requirements. First, the argument must be valid. All invalid arguments are unsound. Second, the premises of the argument must all be true. Any argument that has even a single false premise is unsound. To be sound, an argument must meet both requirements. Let's go back to the example with the purple cats. Is this argument sound? Let's check. The argument is valid, so it meets the first requirement, but it definitely does not meet the second requirement, since not all of its premises are true. In fact, both the premises are false. But not every unsound argument has false premises. Consider another example. Premise 1. All dead parrots are dead. Premise 2. Parrots are not frogs. Conclusion. Therefore, frogs exist. Both premises of this argument are true, so this argument satisfies the second requirement for being a sound argument. However, it doesn't satisfy the first requirement because the argument is invalid. The conclusion does not follow from the premises. So this is an unsound argument, even though all the premises are true. Note that the conclusion is also true, but that doesn't matter. It's still an unsound argument. Here's another example. Premise 1. Ostriches cannot fly. Premise 2. All insects wear top hats. Conclusion. Therefore, ostriches are insects. This argument fails to meet both requirements. It isn't valid, and the second premise is false. So this argument is definitely unsound. Now, you might ask, why should I care whether an argument is sound? The reason is that if we know that an argument is sound, then we know that the conclusion of that argument must be true. There is no way that an argument can meet both requirements for soundness and have a false conclusion. To meet the first requirement, an argument must be valid, and by definition, a valid argument is one where the conclusion cannot be false if the premises are true. And to meet the second requirement, the premises of the argument must all be true. Putting the requirements for soundness together, we can say that a sound argument is one where the conclusion cannot be false if the premises are true, and where the premises are all true. This shows that the conclusion of a sound argument cannot be false. It has to be true. Sound arguments are very useful. They enable us to establish that things are true. Let's finish off by looking at an example. Premise 1. Whales do not have fur. Premise 2. Whales are mammals. Conclusion. Therefore, not all mammals have fur. This argument is valid. If the premises are true, then the conclusion must also be true, and the premises are true. So this is a sound argument, and the conclusion must be true. Give it a try. See if you can write a sound argument of your own.
My name is Ian Olasov. I'm a graduate student at the CUNY Graduate Center, and today I want to talk to you about Bayes' theorem. Bayes' theorem is a fact about probabilities, a version of which was first discovered in the 18th century by Thomas Bayes. The theorem is Bayes' most famous contribution to the mathematical theory of probability. It has a lot of applications, and some philosophers even think it's the key to understanding what it means to think rationally. In order to understand the theorem, though, we'll have to understand a little bit about probabilities. The probability of a proposition is the chance or likelihood that that proposition is true. Suppose you know that one student in a class of 20 has the flu, but you don't know who. If you know that Sally is a student in the class, you would say the probability that Sally has the flu is 1 in 20, or 5%, or 0.05. We can call this your prior probability that Sally has the flu because it's your probability prior to finding out any new information. As a shorthand, we'll write P of Sally has the flu equals 0.05. Suppose now that there are 5 girls and 15 boys in the class. Now, you don't know whether the class's flu patient is a boy or a girl, but if you were to find out that the patient was a girl, your probability that Sally has the flu would go up to 1 in 5, or 20%, or 0.2. On the other hand, if you were to find out that the patient was a boy, your probability that Sally has the flu would go down to 0. Because these things are still iffy, though, remember, you don't yet know whether the flu patient is a boy or a girl, we'll call these things conditional probabilities. Your probability that Sally has the flu conditional on the flu patient being a girl is 0.2. Your probability that Sally has the flu given that the flu patient is a boy is 0. As a shorthand, we'll write P of Sally has the flu given that the flu patient is a girl equals 0.2, and P of Sally has the flu given that the flu patient is a boy equals 0. The little vertical line tells you that we're talking about conditional probabilities. Now, here's the thing. Sometimes you don't know what your conditional probabilities should be. In other words, you know that you might encounter some new evidence in the future, but you don't yet know how that evidence should affect the probability you assign to some hypothesis. Here's where Bayes' theorem comes in. It gives you a way of figuring out what your conditional probabilities should be. So what does Bayes' theorem actually say? Remember our shorthand. Your probability in some hypothesis, let's call it H, conditional on some new piece of evidence, let's call it E, is written P of H given E. Here's what Bayes' theorem tells us. P of H given E equals P of E given H times P of H divided by P of E. In other words, it tells us the 3 ingredients that go into the probability of a hypothesis conditional on some evidence. The probability of the evidence conditional on the hypothesis, the prior probability of the hypothesis, and the prior probability of the evidence. Let's look at an example. Imagine that one morning you don't feel right, and you go on WebMD to figure out what's wrong. You're browsing around until you find an illness that catches your eye, hypothesitis. So the hypothesis under consideration is that you've come down with hypothesitis. As you read through the list of symptoms, you realize that you have all of them. In other words, you have all of the symptoms that you would have if you had hypothesitis. So let's say P of E given H, or P of symptoms given hypothesitis, equals 0.95. You begin to freak out, but then you remember Bayes' theorem. It tells you that there are 2 more things you need to know in order to figure out the probability that you have hypothesitis. the prior probability that you would come down with hypothysitis, and the prior probability that you would have the symptoms that you actually have. With a little more Googling, you discover that the disease is extremely rare. Only 1 in 100,000 people have it. So P of hypothysitis is 0.00001. Now for the last ingredient. What kind of symptoms are they? Suppose they're very common, like a headache and a runny nose. Lots of people have those. Google tells you 1 in 100. So P of symptoms, your prior probability that you would come down with the symptoms you have, is 0.01. At last, you know everything that you need to know in order to figure out the probability that you have hypothysitis given your symptoms. Bayes' theorem tells you that P of hypothysitis given symptoms equals P of symptoms given hypothysitis times P of hypothysitis divided by P of symptoms. In other words, P of hypothysitis given symptoms equals 0.00095, or a little less than 1 in 1,000. Bayes' theorem is very helpful because in figuring out what to make of some new piece of evidence, people often ignore the prior probability of the hypothesis, or treat P of H given E as P of E given H. This mistake is sometimes known as the base rate fallacy. In the case we just looked at, P of H given E is very different from P of E given H. One is less than 0.1%, and the other is 95%. Without Bayes' theorem, you might have gotten a lot more worked up about hypothysitis than you needed to be. Wrapping up then, Bayes' theorem is a formula that tells you how to calculate conditional probabilities, or the probability you should assign to some hypothesis given a piece of evidence. Even if you forget the formula, though, try to remember that the conditional probability of H given E is determined by 3 things: the conditional probability of E given H, the prior probability of H, and the prior probability of E. If you leave one of those 3 things out, you don't have a complete picture.
Hello, I'm Paul Henney and I'm a philosophy graduate student at Duke University. And in this video, I'm going to talk to you about correlation and causation. Maria and Andy are high school students in Arizona. Andy always gets an A on his math test when it's sunny outside. On one sunny day, before Andy goes to math class, he tells Maria, "I'm going to ace this test today because it's sunny." Maria objects. "No, Andy, you'll not ace this test because it's sunny. You'll ace this test because you studied. The fact that it's sunny outside has nothing to do with it." Andy responds, "But Maria, I always ace my tests when it's sunny." Maria replies, "Okay, sure, but that's just because you always study for your math tests, and it's always sunny here in Arizona. The sunniness does not cause you to ace the test." Maria's correct. Andy's making a mistake, right? The sunniness doesn't cause Andy to ace his test. The two events, the sunniness and Andy acing his test, occur together without one causing the other. In other words, the two events are correlated in some way, but there's no causal relation between them. Andy's reasoning here is fallacious. Simply because two events are correlated does not mean that one caused the other. This conflation of correlation and causation is what we will talk about in this video. First, let's consider some other examples. Fido barks when his tail wags. People with higher grades in college have higher grades in high school. People who take vitamin C recover more quickly from a cold. These are correlations. That is, there's a correspondence between these events. For example, the dog, Fido, barks when his tail wags. But there's no reason to suspect that there's a causal relation between these events. While these events often occur together, there are many times when Fido's tail wags and he doesn't bark, and there are times when Fido barks but doesn't wag his tail. Furthermore, we may suspect that there is some common cause for these events, like Fido's excitement when his owner comes home. Now that we can agree that these are cases of correlation without causation, we can discuss 2 types of correlation, positive and negative. In the next video, we'll discuss how these types of correlation specifically relate to different types of causation. But for now, let's just introduce them. When events frequently occur together, like in the examples above, they are positively correlated. If two events are positively correlated, then when one event is present, the other is often present as well. In our first example, it being a sunny day in Arizona is positively correlated with Andy succeeding on his math test. On the other hand, two states are negatively correlated when it's likely that when one event occurs, the other will not occur. For instance, when it snows, it's often not very sunny, so snowing and sunniness are negatively correlated. We often hear about positive and negative correlations, especially in the news. Headlines like, "Taking vitamin C helps you recover more quickly from a cold," indicate positive correlations. Taking vitamin C is positively correlated with recovering from the common cold more quickly than if one had not taken vitamin C. Or headlines like, "Eating more nuts makes you less likely to have higher levels of bad cholesterol," indicates that eating more nuts is negatively correlated with having higher levels of bad cholesterol. You may have heard headlines like these and had conversations with some friends about them. And you may have heard someone say something like, "Awesome, so I'll just eat more nuts and get rid of my bad cholesterol." You may have also had the experience of someone else saying, "Yeah, but that's just correlation, not causation." Of course, this person may just be a jerk, but they are right to point this out. Unless you had evidence that a causal relation held, it is a mistake to suggest that this correlation is actually a causal relation. So it'd be wrong to say that eating more nuts will cause you to have lower levels of bad cholesterol, unless you had evidence that the causal relation held. So let's consider an example where two events are positively correlated when neither causes the other. Consider this again. People with higher grades in college have higher grades in high school. Here, earning higher grades in college is positively correlated with earning higher grades in high school. Now, it's incorrect, as we've discussed, to claim that earning high grades in high school always causes someone to earn high grades in college. Nonetheless, earning high grades in high school may sometimes cause a person to earn high grades in college. For example, Jane may have gotten good grades during high school, and some of those grades transferred to her college, which causes her success in college. Here, success in high school for Jane causes her success in college. But most of the time, it is not the success in high school that causes success in college. It is usually someone's working hard in college courses that causes that person to succeed in college. And at that type level of the statement, where we are identifying a correspondence of two data sets, the causal claim is false. So again, the two events, high school success and college success, are positively correlated, but they do not cause one another. When two events are correlated, it may seem that one causes the other, but there may be alternative explanations we've ignored, like working hard in college courses causes that person's overall success in college. So it's fallacious to conclude from only the fact that two states are positively or negatively correlated that one causes the other, because there may be another cause that explains the outcome. It may be that there's a common cause for both of the events, or that there's some alternative cause altogether. On the other hand, the correlation might just simply be a coincidence. But this explanation and other questions will have to wait for part 2, where we will talk more about the analysis of causation and how it relates to different types of correlation. If you're interested in these false cause fallacies, you may also want to check out our video on the post hoc fallacy. Thank you for watching. To subscribe to Wireless Philosophy on YouTube, click here. Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. And in this video, I'm going to introduce you to formal and informal fallacies. First, consider the following arguments. Premise 1, if someone is allergic to peanuts, then she doesn't eat peanut butter. Premise 2, Jane doesn't eat peanut butter. Conclusion. Therefore, Jane is allergic to peanuts. Consider this other argument. Premise 1. A feather is light. Premise 2. What's light cannot be dark. Conclusion. Therefore, a feather cannot be dark. These arguments probably seemed a bit off to you. And you're right. Each argument contains a fallacy, though each has a different kind. A fallacy, as we've seen in other wireless philosophy videos, is a defect in reasoning. This defect can be unintentional or intentional. That is, I could simply make a mistake in my reasoning, or I could want to trick you into believing something by using deceptive reasoning. Either way, it's probably a good idea that we're able to understand and identify distinct fallacy types so that we can adequately correct any defects in our reasoning. But before we talk about fallacy types, let's recall what a valid argument is. Consider this argument. Premise 1. If someone is a philosopher, then she publishes articles in philosophy. Tamar Genler is a philosopher. Therefore, Tamar Genler publishes articles in philosophy. This is a valid argument. Actually, although it has no bearing on this argument's validity, Genler has published over 20 articles among her other works. This form of argument is called modus ponens, and it can be represented as the following. Premise 1, if X, then Y. Premise 2, X. Conclusion, therefore, Y. And this is a valid argument form. The conclusion necessarily follows from the premises. Remember though, this valid form does not mean that the premises are true. It would still be a valid argument if Tamar Genler had decided to become a train conductor, for instance, instead of a philosopher. See the videos on soundness and validity if you have questions about this. We can also have an invalid argument form. Let's return to our first argument. This argument, as you might have suspected, contains a fallacy, a formal fallacy. And a formal fallacy is exactly what it sounds like, a defect in the form of the argument. In other words, there are certain forms of arguments that are invalid. This invalid argument form is a formal fallacy called affirming the consequent. This fallacy is apparent if you consider that Jane just might not like peanut butter. So simply because Jane doesn't like peanut butter, she doesn't eat it. Given just the fact that she doesn't eat it, and the conditional in premise 1, we cannot conclude that Jane is allergic to peanut butter. This form of fallacy can be represented in the following way. If X, then Y. Y, therefore X. And this form of fallacy is one that you don't want to use. This is actually one of the fallacies frequently tested on the LSAT. So if you're interested and want more practice in identifying this fallacy, check out the video on affirming the consequent. We will talk more about this and other formal fallacies in upcoming videos. But for now, we need to see that formal fallacies are fallacies because of the poor form of the argument. Any argument of these forms will be invalid. So anything can be plugged into these bad argument forms and the argument would be invalid. For instance, if meow, then splat. Splat, therefore meow, is invalid. So now that we have a general understanding of formal fallacies, what about informal ones? Let's look at our other example from the beginning of this video. Notice that this fallacy arises out of the content of the argument, not out of the form. The form may at first glance seem valid, that is, if we ignored the meaning of the concept. Consider that we can use a seemingly similar argument form to make a valid argument. For instance, premise 1, rain is wet. Premise 2, what's wet cannot be dry. Conclusion, therefore, rain cannot be dry. And here we have a valid argument that seems to have a similar form as the fallacious one, and one that lacks defects in its content. But the content of our fallacious argument, given the two meanings of light, light weight, and light color, yields some problems. That is, if we understand the meaning of the terms, the two meanings of light, for instance, we realize that the argument actually has an invalid argument form. Initially, without considering the meaning of the content, it looks like the form of the argument is something like, all x are y. What is y cannot be z. Therefore, no x are z. But actually, given the shifting meaning of light, the form is more like, all x are y. What is w cannot be z. Therefore, no x are z. This fallacy is called equivocation. And see the video on this if you'd like to know more about it. The only way we can understand this defect is by examining the content of the argument. If we just looked at the form without understanding the content, then we could not detect this fallacy. So as we now know, informal fallacies occur because of problems with the content of the arguments. So an argument might have a seemingly valid form, but commit an informal fallacy because of a defect in its content. Hence, an argument might have true premises in a seemingly valid form, yet also commit a fallacy. To reiterate, a formal fallacy means that the argument has a defect in its form, while an informal fallacy has a defect in the argument's content, which might also yield a defect in its form. So now that's the difference between formal and informal fallacies.
Hello, I'm Joseph Wu, and I'm a philosophy graduate student at the University of Cambridge. In this video, I'll be explaining the informal fallacy known as equivocation, a fallacy that comes up all the time. Before we look at some more problematic examples, let's start off with a simple one to see how it works. Consider the following argument. Premise 1. All stars are exploding balls of gas. Premise 2. Miley Cyrus is a star. Conclusion. Therefore, Miley Cyrus is an exploding ball of gas. While this is clearly a terrible argument, the form of this argument appears to be valid, and each of the premises, when considered individually, is true. You might recall from a previous video that an argument with a valid form and true premises is considered sound. You might also recall that a sound argument necessarily has a true conclusion. But you're probably not convinced that Miley Cyrus is an exploding ball of gas, and you're right to think that the logic is flawed. So what's wrong with this argument? This argument commits the fallacy of equivocation. Here, the word star is used with different meanings in the two premises. In the first premise, star is intended to mean something like a celestial sphere of plasma. But then the meaning of star shifts in the second premise, where star refers to a famous person. The premises equivocate between two meanings of the word star. To be precise, equivocation occurs when the same word is used to express different meanings throughout an argument. The arguer is committing a fallacy because he or she uses the word as if that word had the same meaning, and so the argument will appear to be valid, even though it actually is not. Equivocation results from ambiguities in language. Since many words can have more than one meaning, we need to be cautious that key terms do not shift in meaning during the course of an argument. Since equivocation results from multiple meanings of a single term, a helpful strategy to expose this fallacy is to restate the premises of the argument, but without the ambiguous term. For example, let's substitute our definitions of the word star into the premises of the previous example. Premise 1. All celestial spheres of plasma are exploding balls of gas. Premise 2. Miley Cyrus is a famous person. Conclusion. Therefore, Miley Cyrus is an exploding ball of gas. Clearly, this argument isn't valid once we've gotten rid of the ambiguous term, star. Even though both of the premises are true, the conclusion does not follow. This example is surely far-fetched. After all, no one has ever equivocated Miley being a famous person with Miley being an exploding ball of gas. But now that we understand how this fallacy generally works, let's look at two examples that are not so easy to spot. Suppose a respectable newspaper was criticized for spreading celebrity gossip, and suppose that, in response, the editor gave the following argument. Premise 1. Newspapers have a duty to print stories that are in the public interest. Premise 2. The public has great interest in rumors about celebrities, since circulation increases when newspapers print such stories. Conclusion: it's not wrong for respectable newspapers to pass on rumors about celebrities. As with our Miley Cyrus example, this argument appears to be valid. But is it actually? The key term that shows up in both premises of this argument is interest, so let's focus on how it is used. In the first premise, interest is used to mean the benefit of a person or group, like in the sentence, "It is in your interest to keep your bank account information private." In the second premise, interest is used to mean an activity one enjoys doing, like in the sentence, "My interests are swimming, hiking, and reading." Since the meaning of the term interest has shifted between the first and second premises, this editor has committed the fallacy of equivocation. His argument is invalid. Here's another example. Suppose your friend tells you this: organic compounds contain carbon, and organic foods are better for the environment. So when you're grocery shopping, you should look for food that contains carbon in it, as these foods are better for the environment. The absurdity of the conclusion should alert us that something has gone wrong in this argument. So let's take a closer look at how the term organic is being used. The statement "organic compounds contain carbon" is true. This is the scientific definition of organic used by chemists. The next statement, "organic foods are better for the environment," is also true. But note that now, the definition of organic refers to the methods by which that food was produced and processed. The term organic is now used in an agricultural sense, rather than a scientific one. This argument equivocates between two different meanings of organic, so it is invalid. It's worth noting that even if we limit the term organic to its agricultural sense, the threat of equivocation still looms due to the ambiguity of the term. For instance, different countries have different standards for what counts as organic. Different foods also adhere to different standards. And in the United States, there are various categories for labeling organic products, ranging from a product made with 100% organic ingredients to a product made with at least 70% organic ingredients. If you're ever suspicious that an argument is guilty of equivocation, try the method we used in the first example of this video. First, distinguish the potential meanings of the ambiguous term in an argument. Then, restate the argument without the ambiguous term, so that the premises are still true. Finally, evaluate the translated argument. Is it valid? If not, then the argument has committed the fallacy of equivocation.
Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. And in this video, I'm going to talk to you about a particular informal fallacy called the fallacy of composition. In doing this, I'm also going to tell you why there aren't colorless cats, but I'll get to that idea in a second. To recall, an informal fallacy is an argument whose premises do not support its conclusion. Generally, a fallacy is a defect in reasoning, and there are two types of fallacies, formal and informal. A formal fallacy is an argument with an error in the form of the argument, and an informal fallacy contains an error in the content of the argument. But you can learn more about this distinction in the video about informal and formal fallacies, which should be out soon. For this video, we're going to focus on a particular informal fallacy. So, the fallacy of composition is an error in reasoning that arises in the content of an argument. People commit this error when they draw conclusions about the whole from truths about its constituent parts without having a justification for doing so. That is, they think, without justification, that what is true of the parts of something must also be true of the whole those parts compose. Sounds problematic, right? But let's represent this logical error more formally. Reasoning would be something like this. Premise 1, the parts of whole A have qualities X, Y, and Z. Conclusion 1, therefore, whole A must have qualities X, Y, and Z. The argument seems attractive, but the style of argument is like saying that because the states have some set of qualities, then the entire nation must have those qualities. You may now be able to see what's wrong with this line of reasoning. Without sufficient justification, we cannot infer that the whole has the same qualities as its parts simply because the parts have that quality. It may be the case that the whole lacks the qualities that the parts have. It's like saying that because Arizona has an arid climate, the entire nation has an arid climate too. Let's look at a few more examples. It's true that the number 3 and the number 7 are both odd numbers. We might say that 3 and 7 have the characteristic of being odd. Each is also a part of the number 10. 3 plus 7 equals 10. But we cannot say that the number 10 is odd simply because its parts, 3 and 7, have that quality. If we did, we would commit the fallacy of composition. Let's try another example. Suppose your friend made this argument. Premise 1, atoms are colorless. Premise 2, cats, we know, are composed of a bunch of atoms. Conclusion, therefore, cats are colorless too. Well, we know that cats are not in fact colorless, but we can also see where this person made her error. Without justification, she assumed that the whole has the same qualities as its parts. So even though the premises of her argument are true, she committed the fallacy of composition. So we don't have to worry about any colorless cats. So we just learned about the fallacy of composition, or the error in reasoning that comes about when one infers that the whole has the same qualities as its constituent parts. It is important, however, to note that this style of reasoning doesn't always lead to false conclusions. Your friend, for instance, might argue the following. Premise 1, every part of my cat is composed of matter. Conclusion, therefore, my cat is composed of matter. And her argument leads to a true conclusion. The fallacy only arises when we don't have a good reason to infer that the whole has the same qualities as its parts. So remember to stay vigilant of this fallacy and not to worry about any colorless cats. Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. And in this video, I'm going to talk to you about an informal fallacy called the fallacy of division. And I'm also going to discuss why it's wrong to conclude that water molecules are wet. The fallacy of division is a defect in reasoning that arises when someone infers that what is true of something must also be true of that thing's parts. So the fallacy is kind of like saying that because a university has some qualities, then all of that university's departments must also have those qualities. And that's a fallacy because even if a university is good all around, it doesn't necessarily mean that the university has a good taxidermy program, for instance. So, sounds problematic, right? But let's represent the logical error more formally. The reasoning is something like this. Premise 1, whole A has properties A, B, and C. Premise 2, P is a part of A. Conclusion, therefore, P must have properties A, B, and C. The argument seems attractive, but the style of argument will not always lead to true conclusions. For it might not be the case that the parts and the whole have the same qualities. You may now be able to see what's going wrong with this line of reasoning. So let's look at a few examples. Suppose that I have a car, and I made this argument about my car. Premise 1, my car is red and it goes really fast. Premise 2, the muffler is a part of my car. Conclusion, therefore, my car's muffler is red and goes really fast. Okay, that was an easy one. Of course, no one would make this argument or assume that I own a car, but it demonstrates where the style of argument fails. Clearly, the muffler doesn't have the same properties as the car. So let's try another, more familiar example. Suppose that your friend made this argument. The computer is indestructible. The hard drive is a part of the computer. Therefore, the hard drive is indestructible. Now, suppose your friend's premises are true. The conclusion could still be false. Maybe your friend was making this argument in order to transfer the hard drive of the indestructible computer to a different computer. So it would be unfortunate for her to find out that the hard drive is only indestructible when it's connected to the other components of the original computer. So the hard drive itself isn't indestructible, like the whole computer. Your friend committed the fallacy of division. That is, to be precise, she hastily assumed that the hard drive, the part, is indestructible like the whole computer. So we just learned about the fallacy of division, or the error in reasoning that comes about when a person infers that what is true of something must also be true of its parts. It is important, however, to note that this fallacious reasoning doesn't always lead to a false conclusion. I, for instance, might argue the following. Premise 1, the house is pink. Premise 2, the front door is part of the house. Conclusion, therefore, the front door is also pink. And in this case, my argument leads to a true conclusion. For I've, for whatever reason, painted every part of my house pink, simply because there's fallacious reasoning, doesn't necessarily mean that the conclusion will be false. It's interesting to note that this fallacy is also the converse of the fallacy of composition, which says that it's fallacious to infer that what is true of the parts of something is also true of the whole those parts compose. These fallacies are quite similar, so you might want to check out that video as well. Anyway, watch out for this fallacy, and remember that just because water is wet doesn't mean that you can conclude that water molecules are wet too.
Hi, my name is Julianne Chung, and I'm a graduate student at Yale University. Today, I'm going to talk about ad hominem fallacies. Ad hominem is a Latin term that can be translated into English as to the man, which is a very literal translation, or against the person, which is a bit more descriptive. Ad hominem fallacies are also very often called fallacies of personal attack. This is because such fallacies are committed whenever one attempts to challenge a position by criticizing something having to do with its source, thereby shifting attention away from the points at issue and focusing it instead on those who are arguing for them. There are many different kinds of ad hominem fallacies. We are going to briefly survey 6 here. They go by the following names. First, abusive ad hominem. Second, circumstantial ad hominem. Third, tu quoque. Fourth, guilt by association. Fifth, genetic fallacy. And sixth, ad feminam. Abusive ad hominem arguments present personal characteristics of individuals as good reasons to discount their ideas. However, although certain personal characteristics might give us reason for suspicion, they do not affect the virtues of claims considered on their own. Here is an example of such an argument. We should never think that anything politicians ever say is true, because they're all dirty, lying scumbags. It should be easy enough to see that this argument does not give us reason to discount everything that politicians say. Indeed, even those who are the least admirable likely say true things at least some of the time. Whereas an abusive ad hominem argument works by attacking an individual directly, a circumstantial ad hominem argument attempts to challenge a person's position by suggesting that she is advancing it merely to serve her own interests. Although this can be seen as abusive, circumstantial ad hominem arguments differ from abusive ad hominem arguments in that they focus on their target's situations, rather than on their personal characteristics. Once again, however, although such arguments may give us reason to question an individual's intentions, they do not impact whether her claims themselves are nonetheless worth taking seriously. Consider this argument. Summer vacation should be abolished. Any student who argues otherwise should not be listened to because he or she stands to benefit from its continuation. Although we might wonder whether a student who opposes getting rid of summer vacation is doing so solely out of self-interest, that has no bearing on whether it should indeed be eliminated or not, or whether such a student's arguments are any good or not. Plenty of excellent positions and arguments also happen to benefit those advocating them. That does not diminish their merit, however. Another tactic that is often used to attack claims by undermining their advocates' credibility involves allegations of a certain kind of hypocrisy. This fallacy goes by the name tu quoque, which in Latin means you too or you also. When one commits the tu quoque fallacy, one accuses a person of acting in a manner that contradicts some position that she supports, and concludes that her view is worthless on account of the fact that she failed to follow her own advice. However, whether someone is acting in a manner that is somehow in tension with a position she is advancing has no bearing on whether it is right or wrong, although it can admittedly strike us as somehow dishonest or less than noble. Here's an example. I can't believe you're trying to convince me that I should give more money to charity when you don't give nearly as much as I do. Whether the person that this argument attacks, let's call him person B, gives as much money to charity as the person advancing this argument does, let's call her person A, has no bearing on whether person A should or should not give more money to charity. Presumably, that depends on other things besides what B is doing. Say, for example, how much money person A makes, how much money person A presently gives, and so on. The guilt by association fallacy is committed whenever one tries to argue against a certain view by pointing out that some unsavory person is likely to have agreed with it. As in, chocolate chip cookies can't be any good. My philosophy professor loves them, and she is the meanest teacher I have ever had. As we all know, chocolate chip cookies are delicious, despite the fact that some mean people think so as well. A claim can be true despite its being endorsed by someone we don't like. However, while arguments that commit the guilt by association fallacy aim to cast a claim into question by condemning someone who is likely to have agreed with it, the genetic fallacy occurs whenever an attempt is made to cast a claim into question by condemning its origin. Here is an example of an argument that commits the genetic fallacy. The founder of Organization X served time in prison for embezzlement, so we can conclude that the organization must still be corrupt. We can imagine this argument being advanced in order to argue against a claim to the effect that Organization X offers many excellent services and deserves financial support. However, the mere fact that the founder of Organization X was a criminal does not show that the organization currently acts in a way that is morally unacceptable. Things could have changed a lot since then. As a note, arguments that commit the genetic fallacy can also be used positively to support claims, rather than undermine them. The last fallacy that I am going to talk about today goes by the name ad feminam. Ad feminam arguments attempt to discredit a claim on the grounds that a female person proposed it. Such arguments often include statements to the effect of, "Why should I believe anything you have to say? After all, you're just a woman." I take it to be more or less obvious as to why such arguments are deeply problematic. How about this example? Does it commit one of the fallacies just considered? If so, which one? Ronald Reagan was in favor of similar policies, so they must be the right thing to do.
Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. And in this video, I'm going to talk to you about an informal fallacy called ad hominem. The phrase ad hominem might sound a bit bombastic, but I assure you that it's an interesting and useful critical thinking tool. The Latin phrase roughly means to the person, and that's exactly what this fallacy is. It's an attack against the person making the argument rather than an attack against the argument itself. But let's see if we can pin down exactly what this means by using an example. Suppose that my friend Vlad made the following argument. Cats stay indoors and use a litter box. While dogs need to be walked and they have to run outside, dogs are just more work. Therefore, cats are better domestic pets than dogs. And then I would reply, yeah, Vlad, but you're a total jerk. So I disregard Vlad's argument in favor of cats and decide to get a dog. So let's think about my reply to Vlad's argument. Maybe you think that my reply is a completely good response to Vlad. Suppose it's true that Vlad is a total jerk, and that I think no one should respect him or listen to what he says. I think Vlad has bad character in some way, therefore his argument should be rejected. So my response is good, right? If this example doesn't convince you, suppose that Vlad is really Hitler. Hitler is a total jerk, so his conclusion is false, or his argument is invalid. Does that sound good? But let's represent my argument more generally to see why this reasoning is actually flawed. Premise 1. Person P makes claim C. Cats rule, dogs drool. Premise 2. Person P has unsatisfactory standing or circumstance. Vlad is a total jerk. Conclusion. Therefore, claim C is false. It's false that cats are better domestic pets. While it might seem appealing in some cases to say that this is a good argument form, it would be generally wrong to think so. The standing of the person making the argument, in most cases, will be irrelevant to the validity or the soundness of the argument. And this is the misconception that I would like to correct in this video. Simply because Vlad is a total jerk doesn't mean that his claim about cats as better domestic pets is false. He could be a complete jerk, yet still make a good argument in favor of cats as domestic pets. So let's look more closely at this fallacy and at its 4 subtypes. The first type of ad hominem fallacy is the abusive type. To understand this type, let's return to our first example where I called Vlad a jerk. In this case, I've committed the abusive ad hominem fallacy. In other words, I've attacked or abused the person making the argument. I haven't criticized the argument itself. More specifically, I've abused Vlad by simply attacking his character, and then I equated his poor character with his argument. This is a fallacy because while the speaker, Vlad, might not have good standing as I see him, his argument may still be valid. That is, cats might be better domestic pets. Another type of ad hominem fallacy is the circumstantial type. Let's suppose that when I'm talking to my friend Catherine, she makes the following argument. Premise 1. Animals are sentient beings. Premise 2. If a being is sentient, then killing it for food is immoral. Conclusion. Therefore, killing animals for food is immoral. Suppose then that I make the following statement in reply. Yeah, but Catherine, you work for a vegan food company, so your argument must be invalid. In this case, I attack Catherine's circumstance, that she works for a vegan food company, instead of her argument. Maybe I thought that she may have a conflict of interest in making her argument. That is, she wants to sell more vegan food products. So she may be motivated to give a faulty argument in favor of veganism. Despite this potential conflict of interest, my reply to her argument does not effectively criticize her argument. Although she works for a vegan food company and may have a conflict of interest, she may also have a perfectly valid and sound argument supporting her conclusion that killing animals for food is immoral. If I wanted to effectively combat her argument, I could maybe argue that animals aren't sentient or attack some other premise in her argument. The third type of ad hominem fallacy is called tu quoque, which roughly means you also. To explore this variation of the fallacy, let's return to our previous example. But suppose that my reply to Catherine's argument were, yeah, Catherine, but you eat meat, so you support the killing of animals for food. Your argument must be invalid. In this case, I highlight Catherine's standing in that she doesn't act in a way that's consistent with her conclusion. I take her hypocrisy to invalidate her argument, or at least to be a reason to reject her conclusion. But again, my reply doesn't effectively critique Catherine's argument. I've not even mentioned any problems with the premises or the conclusion at hand. So despite her purported hypocrisy, Catherine might have an effective argument and just think that it's immoral that she eats meat. The last type of ad hominem fallacy is the guilt by association type. Let's suppose now that my response to Catherine's argument is this. Yeah, Catherine, But towards the end of his life, Hitler was a vegetarian. So you might have made a similar argument. Since we'd reject his argument simply because he is Hitler, the most evil person in the world, we should obviously reject your argument too. What have I done in this case? Well, I've associated Catherine with a person of very poor character. And then I've suggested that it is a reason to reject Catherine's argument. This, however, is fallacious because while Hitler was a terrible person who committed some of the most atrocious acts in history, he still may have made a valid and sound argument about the morality of eating animals. Moreover, Catherine's slight association with Hitler does not invalidate her argument. And by discussing your character, I have not even addressed the issue at hand, veganism. Let's look at the fallacy in our general schema. The arguments that I've been making against Catherine are of the following form. Premise 1, Catherine claimed that killing animals for food is immoral. Premise 2, but she has poor standing or circumstance. Conclusion, therefore it is not the case that killing animals for food is immoral. Have I committed an informal fallacy in these cases? Yes, I have not invalidated or even addressed the subject of Catherine's argument. Rather, I have personally attacked her standing and character. This is the ad hominem fallacy, and you will see it often. It is important to note also that philosophers have many questions and concerns about this fallacy and when a person's standing and character are relevant to an argument. But we will have to save these questions for another video. Hello, I'm Paul Henney, and I'm a philosophy graduate student at Duke University. In this video, I'm going to talk to you about an informal fallacy called post hoc ergo propter hoc. In doing this, I'm also going to tell you why it's sometimes wrong to conclude that a cat scratch caused your fever, but I'll get to this idea in a bit. Let's start with a problem. Suppose that one day I decide to work from home, and my roommate Alex asks to use my bike. And of course I let him. So he takes my bike and goes to work. Later that day, he returns home with my bike. Only the chain is busted. I say, Alex, you broke my bike. You caused the chain to break. You're responsible for this. He rode my bike, and then it broke. It seems as though he caused it to break. So he should be responsible, right? But is this the correct conclusion for me to draw? Did Alex cause my bike to break? What do you think? I'd like to suggest that that's the wrong conclusion to draw. Well, it's wrong for me to conclude this without gathering more evidence that Alex was negligent while riding my bike. Or it could be the case that the chain on my bike was defective in some way, and that whoever rode my bike that day, maybe me, would have returned home with a broken bike. In this scenario, I've committed the post hoc ergo propter hoc fallacy. Post hoc ergo propter hoc is a Latin phrase roughly meaning after this, therefore, because of this. Here is the idea. It's a fallacy to argue that because one event, like my bike breaking, occurred after another event, like Alex riding it, the first event caused the second event. Let's represent this formally. Premise 1. X happened after Y. Conclusion. Therefore, Y caused X. Returning to our example, my argument now looks like this. Premise 1. My bike broke after Alex rode it. Conclusion. Therefore, Alex caused it to break. So, is this a valid argument? What do you think? As it is now, the argument is invalid. Here's a counterexample. The sun sometimes comes out after it rains, but that doesn't mean that the rain caused the sun to come out. But let's be more charitable to my invalid argument. Maybe we can add a few premises, implicit ones, to make it valid and to make it seem more reasonable. Let's try this. Premise 1. My bike broke after Alex rode it. Premise 2. Usually the person who rides the bike before it broke caused it to break. Conclusion. Therefore, Alex caused it to break. But this argument is now inductive, which is fine. However, it shows us that we need more evidence that Alex broke my bike in order to conclude that he broke it, as opposed to the bike just breaking no matter what. So let's consider two cases with more or less evidence. Case 1. Suppose my other roommate, Aaliyah, saw Alex hitting my bike chain with a hammer, and then she told me about it. If this were the case, I would have better evidence, a better case for concluding that Alex broke my bike. So let's consider now case 2. Suppose Aaliyah did not see Alex hitting my bike with a hammer. I can conclude, although hastily, that it's only likely Alex who broke my bike, though I'm still committing the fallacy in this case, and I need more evidence, like the testimony of my roommate. Let's take another stab at my argument. Premise 1. My bike broke after Alex rode it. Premise 2. If a bike breaks after someone rides it, the rider caused it to break. Conclusion. Therefore, Alex caused my bike to break. Is this argument valid? Yes. But wait, is it sound? Let's check. Is premise 1 true? Yes. Is premise 2 true? No. Plenty of bikes break without the rider causing it. So suppose Alex didn't act negligently at all. Like I said earlier, the bike could have been worn out, so no one acted negligently. It's just natural wear and tear of the bike, and the natural wear and tear caused the bike to break, not Alex. Here, premise 2 is false. Regardless of the exact argument representation I use, I need more evidence about this case for me to make my conclusion. If I don't have evidence that Alex acted negligently, I'll not have a good argument. I'll make a hasty conclusion, and I'll commit the post hoc fallacy. We can see now that this after this, therefore because of this reasoning is defective. A cat might have scratched you right before you got a fever, but that doesn't mean that the cat scratch caused your fever. It's perfectly possible that the flu that your roommate recently had was the actual cause for your fever. The sequence of the two events alone does not establish a causal relation between them. You probably have a lot of questions about this fallacy now, and there's a lot more to talk about, like causation, controlled experiments, possibility, and superstitions, but unfortunately, they'll have to wait for other videos.
Hi everyone, my name is Jordan McKenzie, and I'm a graduate student at the University of North Carolina at Chapel Hill. I'm going to talk to you today about a type of informal fallacy known as the argumentum ad populum fallacy or the appeal to the people fallacy. Now let's start with a walk down memory lane. Do you remember ever trying to cajole your parents into buying you the latest fad toy, say a Furby, by whining about how everyone at school thought that Furbies were the best toy ever, so they must really be the best toy ever? Your parents probably responded by saying something like, "If everyone at school jumped off a cliff, would you jump off a cliff?" Your parents were, in fact, calling you out for making an appeal to the people. And for reasons that will become clear as you watch this video, they were perfectly right to do so. Let's take a closer look at how this fallacy works. An appeal to the people tries to establish the truth of some claim P on the basis that a lot of people believe P to be true. Because it's an informal fallacy rather than a formal fallacy, we know that there's something wrong with its content rather than its form. In this case, the content that the argument provides in support of its conclusion simply isn't sufficient, or even necessarily relevant, to establishing the truth of that conclusion. An example will help clarify things. Suppose you and your friend are arguing over whether or not Justin Bieber has any musical talent. Your friend says, "Of course he has musical talent. Millions upon millions of fans can't possibly be wrong." If you wanted to formalize your friend's argument, it would look something like this. Premise 1. Millions of people think Justin Bieber has musical talent. Conclusion. Therefore, Justin Bieber has musical talent. Now, if you think there's something fishy about this argument, you're right. The big problem with this argument is that it tries to establish the truth of its conclusion, that is, that Justin Bieber has musical talent, by appealing to the fact that many people believe that conclusion to be true. But this simply doesn't follow. Something can be true even if everyone believes it to be false, and something can be false even if everyone believes it to be true. Now, I don't mean to say that we should always completely disregard popular opinion when we're trying to figure out whether or not something is true or false. Often, the fact that most people believe in the truth of some claim does actually give us at least some reason to think that that claim really is true. If, for example, you find out that 98% of your sociology class thought that the answer to question 5 on the exam was C, it would be reasonable for you to think that C probably was indeed the right answer. After all, if they all managed to arrive at that answer, it was probably because they properly studied for the test. You would be committing a fallacy, however, if you thought that the answer to question 5 was C because 98% of your sociology class had answered the question that way. So, while popular support may give you a reason to believe a claim to be true, it is very rarely itself the thing that makes that claim true. Note that I said very rarely and not never. In fact, there are a few cases in which appeals to popularity are not fallacious. Consider etiquette. If I'm trying to argue that it is rude in India to leave one's shoes on indoors, it is very reasonable for me to appeal to the fact that most people in India think that it's rude to leave one's shoes on indoors. In this case, the content to which I am appealing, that is, the opinions of the Indian population, is completely relevant to the conclusion that I am trying to establish. Or, suppose that you are having an argument with a friend about how this letter is pronounced in Canadian English. Here's a situation where there would be nothing wrong about making an argument like, almost everyone in Canada says Z, so the correct pronunciation in Canadian English must be Z and not Z. Keep in mind, however, that these examples are the exceptions and not the rule. Most of the time, it's a good idea to be suspicious of arguments that attempt to establish the truth of a conclusion by appealing to popular opinion.
Hi, I'm Joseph Wu, and I'm a philosophy graduate student at the University of Cambridge. In this video, I'll explain the strawman fallacy, an informal fallacy that comes up all the time. Let's start off with an example to see how it works. Suppose my friend Maureen presents the following argument. Premise 1. Advertisements for beer encourage underage drinking. Premise 2. Underage drinking often has negative consequences. Conclusion. Therefore, advertisements for beer should be banned from TV. And let's say I respond with the following objection. Well, yeah, but people will never give up drinking beer. They've been doing it for ages. Is this a good response to Maureen's argument? No, because Maureen never claims it would be a good idea to give up drinking beer. That's not her argument at all. In this scenario, I've committed the strawman fallacy, since I've attacked a position that Maureen never advances. The straw man, or straw person, fallacy occurs when an opponent's position is misrepresented in order to make it easier to critique. Just like how a man made of straw is intended to resemble an actual man, a straw man fallacy occurs when an opponent's position is presented in a way that resembles the original claim, but is not the actual claim advanced. It creates the illusion that a position has been refuted or critiqued by switching out the original position with a different one. To see this more clearly, consider the following two claims. Advertisements for beer should be banned from TV. This is Maureen's original claim. People should stop drinking beer. This is my portrayal of Maureen's original claim. And these are two very different claims. Maureen only endorses the first one based on our conversation. However, my objection is to the second claim, which is much easier to refute. This is because the second claim is a very extreme view. It would take a lot of good arguments to convince others that people should stop drinking beer. But in our argument, I have improperly attributed this extreme view to Maureen, and then proceeded to attack it. Since this claim is much easier to refute than her original claim, I have committed the strawman fallacy. The general structure of strawman fallacies goes like this. First, person 1 advances position X. Second, person 2 presents a distorted version of position X. Let's call this position Y. Third, person 2 attacks position Y. And fourth, person 2 concludes that position X is false. In the strawman fallacy we've just considered, The original view was exaggerated to a very extreme view and then attacked. But there are other ways in which a position can be misrepresented as well. Sometimes a position can be oversimplified to the point of being absurd. Here's an example of that. Suppose my friend Geo presents the following argument. Premise 1. The theory of evolution says that humans are no different from apes. Premise 2. Humans are different from apes because humans are obviously smarter. Conclusion. Therefore, the theory of evolution is false. Is this a good argument? Clearly not, since the theory of evolution does not claim that humans are no different from apes. Geo has falsely characterized what the theory of evolution says and then proceeded to attack it. He has committed the straw man fallacy. But it's worth noting that the structure of his argument is valid. So for anyone not familiar with evolutionary theory, it might seem as if Geo has provided a good argument against evolution. And this is why straw man fallacies can often be difficult to spot. The straw man fallacy is prevalent in politics as well, and it is not just used to misrepresent an opponent's position. Often, straw men are set up to distract people from difficult topics that politicians want to avoid. For example, consider how politicians construct straw man responses by answering a question they were never asked. Suppose a politician is being accused of illegally using campaign funds for personal use. Let's say a reporter asked the politician directly, "So, did you or did you not use campaign funds for personal spending?" And the politician might respond with something like this. "That's an excellent question. I've received a lot of generous donations to my campaign. My favorite donation has been a handwritten card thanking me for everything I've done. I really love that card, especially since I value the dedication of working class people." In this example, the politician sets up a straw man by responding to a different question than the one originally asked. The question was whether campaign funds have been used for personal spending, but the politician provides an answer to the question, "What has been your favorite campaign donation?" This is a much easier question to answer, and it allows the politician to avoid answering the original question while also portraying himself or herself positively. Strawman fallacies are everywhere, and you've probably come across variations of the examples presented here in your everyday life. Sometimes strawman fallacies are intentional, which is often the case in politics, but other times they are unintentional, like when someone genuinely misunderstands an opponent's claim. In order to keep discussions productive, it is important to grasp the exact position being advanced before proceeding to attack it. Otherwise, you may be guilty of committing the strawman fallacy.
Hello, I'm Joseph Wu and I'm a graduate student at Cambridge. In this video, I'll explain the slippery slope argument, a rhetorical strategy that is sometimes compelling, but other times fallacious. Let's start off with an example to see how it works. Imagine you take out a pack of gum during class, and your friend Dan sees this and asks for a piece. Let's suppose you respond by saying, "Sorry Dan, I can't. If I give you a piece, then I'll have to give the next person who asks a piece as well. Pretty soon, I'll have to give everyone in class a piece, and then there will be none left." In this scenario, you've given a slippery slope argument in response to Dan. A slippery slope argument claims that once one event occurs, other related events will follow, and this will eventually lead to undesirable consequences. The basic idea is that once you take that first step down the slope, such as giving Dan a piece of gum, then you keep slipping down until you reach the disaster at the bottom, like providing everyone in the class gum. To see this more clearly, another way to think about slippery slopes is as a chain of events. If you give Dan gum, then everyone else will see. If everyone else sees, then they will also ask for gum. If everyone else asks, then you'll have to give the entire class gum. Therefore, if you give Dan gum, then you have to give the entire class gum. To clarify the general structure of the argument here, let's take this chain of events as premise 1. Premise 2 would then be, giving the entire class gum is unacceptable. Premise 3, you should not do what's unacceptable. Conclusion, therefore, you shouldn't give Dan gum. How convincing is this slippery slope argument? Here are 3 questions we can ask to highlight some possible objections. First, are any of the claimed effects really that bad? This question evaluates how undesirable the bottom of the slope really is. For example, Dan could object that actually, it would be great to give the entire class gum, since then everyone would have minty breath. And if that's right, then Dan can challenge the second premise by arguing that, in a sense, giving the entire class gum is acceptable. Second, are any of the claimed effects actually likely to follow? This question evaluates how slippery the slope actually is. Perhaps one link in the chain of events does not lead to the next, which would lead us to reject the first premise. For instance, Dan could argue that even if everyone sees you give him gum, no one else will ask for a piece. If this is right, then the slippery slope has a stopping point, and the argument is unsound. To learn about what makes an argument sound, check out Wi-Fi's video on soundness. Third, of the likely events to follow, do the costs outweigh all the benefits of what is being critiqued? This question asks whether there might be other relevant factors to consider before accepting the conclusion. For example, Dan could concede that it's likely that a few other classmates who see your gum will ask for a piece. But then, Dan could argue that all things considered, the benefits of giving him gum still outweigh these costs. For example, maybe, because Dan is your very good friend, you shouldn't be bothered by losing some gum in the process of giving him a piece. Now that we have a good sense of how to identify and respond to slippery slope arguments, let's consider a slightly different version of them. Suppose I'm driving 66 miles per hour on the freeway, and I'm pulled over because the speed limit is 65. I might argue to the police officer that I shouldn't get a ticket, since going only 1 mile per hour over the limit is insignificant. What happens if the police officer accepts this argument? Well, the next person pulled over for speeding at 67 miles per hour can argue, hey, you let Joseph off when he was going 66 miles per hour, and you already admitted that 1 mile per hour is an insignificant difference. So, by the same logic, you have to let me off as well. Pretty soon, the police officer will be in trouble, because the next person clocked at 68 miles per hour can make the same argument again. Eventually, the officer will have to let everyone off without a ticket, no matter how fast they are going. The logic of this argument is extremely slippery, because the first few steps are the easiest to take. After all, it does seem unfair and arbitrary to fine someone going 66 miles per hour when another driver going just 1 mile per hour slower is not fined. But note what happens when the officer accepts my initial argument. 2 important premises are granted. First, 1 mile per hour is not a significant difference in speeds. And second, if 65 miles per hour is acceptable, then so is 66. The trouble comes when this first premise is applied again to the difference between 66 and 67 miles per hour, and then 67 and 68 miles per hour, and so on. Once this type of argument gets started, it may be too late to decisively stop it, at least without being inconsistent. You're on the slippery slope, sliding down to an absurd conclusion. Here's one last example for viewers to evaluate on their own. In 2012, the mayor of New York City proposed a ban on large sugary drinks in city restaurants. While some favored the ban for the sake of public health, others opposed it. One common argument against it was this: the proposal restricts my freedom of choice. If the government can tell me I can't buy large sodas, then what is the government going to tell me next? What time to go to bed? How big my steak should be? How plausible is this slippery slope argument? To answer this, use the 3 questions introduced earlier to evaluate it, and let us know what you think in the comments. Variations of the slippery slope argument are everywhere. While they are sometimes compelling, other times they are not. Have you heard of a slippery slope argument recently? If so, please share it below. Thanks for watching. To subscribe to Wireless Philosophy on YouTube, click here. Hello, My name is Geoff Wu and I'm a graduate student at Cambridge. In this video, I'll explain the red herring, a rhetorical device and fallacy that is often difficult to spot. Let's begin with an example from law. Imagine an attorney prosecuting a person for murder. The attorney stands up before the jury and says this: "The defendant today is guilty of a horrendous crime. He murdered the victim not with a gun, not with a knife, but with a chainsaw. This was an awful way for the victim to die." Is this a good argument? Given the tools of logic we've learned from Wi-Fi, not really. The attorney is supposed to be arguing for the claim the defendant committed murder, but the attorney appears to be arguing for a slightly different claim. Being killed with a chainsaw is an awful way to die. Notice, however, that the second claim does not provide evidence for the first. It doesn't follow from the fact that death by chainsaw is horrible that the defendant actually committed the murder. In this scenario, the attorney has used the red herring since she's distracted the jury with a point that seems relevant, but actually is not. A red herring occurs when something is introduced to an argument that misleads or distracts from the relevant issue. The term originates from a past practice that involved dragging a strong-smelling red herring across one's trail to throw dogs off the scent. Similarly, people often introduce irrelevant details into an argument to divert attention from the real issue at hand. The red herring falls under the broader category of fallacies of relevance. These are fallacies that arise when a premise, whether true or not, is not adequately related to the conclusion. Two other common fallacies of relevance are appeals to authority and ad hominem arguments. Of course, the attorney probably intentionally introduced the red herring in her statement. The attorney may be trying to establish a link in the jury's mind between these two seemingly related claims. Once the jury reflects on how horrible it would be to be killed with a chainsaw, they might begin associating the crime with the defendant instead of questioning the attorney's assumption that the defendant actually committed the crime. So while some red herrings are accidental, often they are intentional. This is especially true in politics. Suppose a reporter asks a politician this: "How will you improve access to healthcare?" And the politician responds, "It's a tough issue. Many good things are happening in healthcare now, like the recent bill that increases cancer research funding. It's like our foreign policy. I'm making good things happen there too." This is a classic red herring on many levels. First, the politician deflects the issue of healthcare access to foreign policy, hoping to shift the attention to another subject. Second, the politician points to the recent bill that increases cancer research funding. Though related to healthcare, it's unclear how more cancer research funding is relevant to healthcare access. These are two separate issues. The tactic here is to divert attention to a seemingly related subject everyone can agree upon. Since presumably everyone thinks more cancer research funding is good, the politician can deflect attention to this agreement and avoid the more controversial question on healthcare access. Finally, the bill to increase cancer research funding may itself be a red herring if it fails to address the root issues in healthcare. Often, policies generate vigorous debate because they are flashy or controversial, but ultimately distract from meaningful reform. Consider another example of how red herrings can be used to manipulate the media. One way to do this is to make outlandish statements that make good stories. Suppose, for instance, you accuse your political rival of being unfit for office because he hates pizza. Clearly, one's dislike of pizza is irrelevant to one's political abilities, but the absurdity of the claim is enough to spark a conversation that ultimately distracts from more meaningful issues. This can be a very powerful strategy. If the media spotlight is on the ridiculous pizza claim, this gives yourself more coverage, and it prevents your opponent from controlling the conversation. Here's one last example. Suppose you are debating the best drink to have with dinner, and your friend argues this: "Look, whiskey is amazing. It's delicious. I once traveled to Scotland, which is a gorgeous country, and they just have the nicest people there. It was a great time. And even when I traveled to France, the wine was delicious, but I'd still rather have whiskey with dinner." There's not much here that supports the conclusion that whiskey is the best drink with dinner. In fact, the passage is full of tangents that make it hard to follow the argument. This maneuver is a version of the red herring in which unnecessary details are included, often to confuse opponents or hide gaping holes in an argument. As a result, it becomes extremely difficult to criticize the argument when it is so difficult to identify. To some, red herrings can take a number of different forms, such as arguing for the wrong conclusion, responding to the wrong question, making outrageous claims, going on tangents, and offering shallow responses that fail to address the issues at stake. Have you heard of a red herring recently? If so, please share it below. Thanks for watching. To subscribe to Wireless Philosophy on YouTube, click here.
Hi, my name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about A-leaves. This lecture is part of a series on cognitive biases. Imagine that you're visiting the Grand Canyon and you decide to take a walk on their skywalk, a huge glass bridge suspended above the raging waters of the Colorado River. Now imagine that you head out to the middle of the skywalk and look down, and you see your feet resting on the clear glass, standing 4,000 feet up. How do you think you would feel? If you're like most people, you might feel pretty terrified. Your heart would beat faster, your palms would get sweaty, you might grip on the railing just a little bit tighter. But the fact that you feel this scared is pretty weird. After all, the skywalk is perfectly safe. It's bolted in place with hundreds of steel girders. It's exactly as strong as it would be if it were made with an opaque floor, and even stronger than it would be if it were only 400 or 40 or even 4 feet in the air. It's basically as solid as anything you have ever set foot on before. You also have lots of data showing how safe it is. Thousands of visitors walk along the skywalk every single year, and not a single one of them has fallen through. It's safer than crossing the street or riding in a car or even standing on a regular balcony. So why do you get so scared? What's going on? The disconnect between your belief that the skywalk is perfectly safe and your sense that you might fall to your death shows the power of what are known as A-leaves. A-leaves are automatic or habitual belief-like attitudes. They're the way we instinctively respond to stuff that we instinctively like or dislike, or even stuff that we're just really used to. The term A-leaf was coined by the philosopher Tamar Gendler. She decided to use the word A-leaf because A-leaves are kind of like B-leaves, except they're affective and associative and automatic and irrational, so she called them A-leaves. When you're standing on the skywalk, you believe that you're perfectly safe, otherwise you wouldn't have stepped out there, but you also simultaneously A-leave that you're at risk for falling, hence the sweaty palms. And that's the interesting thing about A-leaves. They don't necessarily track what we actually believe to be true, like the fact that you'll be perfectly safe on the skywalk. The problem is that even when we realize our A-leaves don't reflect reality, that they don't match what we believe to be true, that they're perfectly irrational, our A-leaves don't just go away. They stick around and guide many of our behaviors anyway. It's this stickiness of A-leaves that makes them so strange. That's the reason we get scared at horror movies like Jaws, even though we know that the shark in the movie is just a bunch of plastic. And as the psychologist Paul Rozin famously showed, that's why we wouldn't want to eat a yummy piece of chocolate that's shaped like this. And as the cognitive scientist Fiery Cushman showed, that's why you don't like using a hammer to do this, even when you know the hand is just plastic. But A-leaves are also at work in more serious cases. If you've lived in a society structured by a legacy of racial bias, you may believe that African Americans and Caucasians are equal, but your A-leaves may reflect a whole host of implicit racial biases. If you have lived in a society where men tend to be doctors and women tend to be nurses, you may believe that women are just as good at men as science, but your A-leaves might be different. And, as many psychologists have recently shown, those biased A-leaves may play a bigger role in your hiring decisions more than you might think. So next time you hesitate to touch a plastic spider, or cry at a sad but fictional movie, or even notice some of your mistaken biases, you'll know that these are your powerful A-leaves at work. My name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about anchoring. This lecture is part of a series on cognitive biases. Let's do a math problem really quickly, and you've got to do it in your head. Ready? First, multiply the following numbers: 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, that's it. What's your guess? 1,000? 2,000? When the psychologists Danny Kahneman and Amos Tversky tried this with human subjects on average guessed about 2,250. Seems like an okay guess. But now, let's suppose I gave you a different math problem. What if I gave you this one? Ready? 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. What's your answer? If you're like Kahneman and Tversky's subjects, your answer might be a bit different here. For this question, their subjects guessed a lot lower. On average, they said the answer was about 512. The first amazing thing about these similar mathematical estimates is that people get the answers really wrong. In fact, the real answer? Well, for both, it's 40,320. People are off by an order of magnitude. But the second, even more amazing thing is that people give different answers to the two problems, even though they're just different ways of asking exactly the same question. Why do we give completely different answers when the same math problem is presented differently? The answer lies in how we make estimates. When you have lots of time to do a math problem, like 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, you can multiply all of the numbers together and get an exact product. But when you have to do the problem quickly, you don't really have time to finish. So you start with the first numbers, you multiply 8 times 7 and get 56, and then you've got to multiply that by 6, and well, you're guessing the final number's got to be pretty big. Bigger than 56, like maybe 2,000 or so. But when you do the second problem, you start with 1 times 2, and well, that's only 2, and 2 times 3 is only 6. Your answer is going to be pretty small, maybe only like 500 or so. This process of guessing based on the first number you see is what's known as anchoring. The first number we think of when we do our estimate is the anchor. And once we have an anchor in our head, well, we sort of adjust as needed from there. The problem is that our minds are biased not to adjust as much as we need to. The anchors are cognitively really strong. In the first problem, you probably started with 56 and then adjusted to an even bigger number from there. And in the second problem, you started with 6 and then adjusted from there. The problem is that starting at different points leads to different final guesses. Like real anchors, our estimated anchors kind of get us stuck in one spot. We often fail to drag the anchor far enough to get to a correct answer. Kahneman and Tversky discovered that this sort of anchoring bias happens all the time, even for anchors that are totally arbitrary. For example, they asked people to spin a wheel with numbers from 1 to 100, and then asked them to estimate what percentage of countries in the United Nations are African. People who spun a 10 on the wheel estimated that the number was about 25%. But people who spun a 65 estimated that the number was 45%. In another experiment, Dan Ariely and his colleagues had people write down the last 2 digits of their Social Security number. They were then asked whether they would pay that amount in dollars for a nice bottle of wine. Ariely and colleagues found that people in the highest quintile of Social Security numbers would pay 3 to 4 times as much for the exact same good. Just setting up a larger anchor can make a person who would pay $8 for the bottle of wine be willing to spend $27 instead. Sadly for us, salespeople use anchors against us all the time. How many times have you noticed a salesperson or an advertisement anchoring you to a particular price, or even to how much of a particular product you should buy? Whether it's buying a car or a sweater, or even renting a hotel room, our intuitions about what prices are reasonable to pay often come from some arbitrary anchor. So the next time you're given an anchor, take a minute to think. Remember what happens when you drop your anchor too high, and then consider thinking of a very different number. It might affect your final estimate more than you expect. My name is Laurie Santos. I teach psychology at Yale University. and today I want to talk to you about pricing biases. This lecture is part of a series on cognitive biases. Congratulations! You've just won a raffle, and your prize is a bottle of wine. Here are your choices. Option number 1 is a lovely bottle of California Pinot Noir that costs $20. Option number 2 is another bottle of Pinot Noir from the same region that costs $50. Which would you choose? If you're like most people, you probably went with the more expensive wine. People tend to pick the most expensive option, whether their choices involve wine or meats or even cassette players. What's a bit weirder, though, is the fact that we still like higher priced goods, even when we know that the price is totally arbitrary. One experiment that showed this bias at work was done by the neuroscientist Hilke Plassman and her colleagues. They allowed people to taste a glass of wine from 2 bottles that were labeled as either $10 or $90. What they didn't tell participants, however, was that the 2 bottles were identical. They contained exactly the same wine inside. Even though the wines should have tasted identically, people reported liking the wine with the more expensive price tag even better. It seems that merely labeling one thing as more expensive makes us like it more. We seem to be confusing a good's price with its value. This confusion is what's known as a price effect. Simply telling someone that something costs more makes them like it more. And the effect seems to hold for lots of different kinds of goods. You might be tempted to think that people aren't as fooled as it seems in Plassman and colleagues' studies. Maybe people just say they like expensive stuff better, even though they don't really subjectively feel like it's better. Plassman and her colleagues worried about that too, which is why they used a pretty ingenious technique to test whether subjects actually liked one wine better than the other. Rather than just asking subjects, they used brain imaging techniques to test how people's brains process the same wine with different price tags. They found that the parts of a subject's brain that process rewards, the same spots that would fire a lot if you won some money or saw an attractive mate, or even tasted an amazing dessert, fired more for the very same wine when it was labeled with a higher price tag. So our pricing biases appear to affect more than just the subjective evaluations we report on a survey. We seem to like higher priced things more, even at the level of the reward areas in our brains. But arbitrarily higher prices don't just affect what we like. They can also affect how well a given product works. The behavioral economist Baba Shiv and his colleagues let people pay different amounts for an energy drink, and then tested how those drinks worked. Did they make people more or less energized? Shiv and his colleagues found that people reported feeling more energized after drinking the very same energy drink with a higher price tag. But they also did better on a set of mental acuity puzzles. Somehow participants really were more energized after a drink with a high price tag than when drinking an identical drink with a lower price tag. These results suggest that the price we pay for an aspirin or a bottle of wine or even an energy drink doesn't just affect what's in our wallets. Because of price biases, our minds assume that higher prices mean better quality, even in cases where the price of a good is totally arbitrary. My name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about reference dependence and loss aversion. This lecture is part of a series on cognitive biases. Imagine that you're a doctor heading a medical team that's trying to fight a new strain of deadly flu, one that's currently spreading at an alarming rate. The new flu is so devastating that 600 million people have already been infected, and if nothing is done, all of them will die. The good news is there are 2 drugs available to treat the disease, and your team can decide which one to put into mass production. Clinical trials show that if you go with the first drug, drug A, you'll be able to save 200 million of the infected people. The second option is drug B, which has a 1/3 chance of saving all 600 million people, but a 2/3 chance that no one infected will be saved. Which drug do you pick? You probably thought drug A was the best one. After all, with drug A, 200 million people will be saved for sure, which is a pretty good outcome. But now imagine that your team is faced with a slightly different choice. This time it's between drug C and D. If you choose drug C, 400 million infected people will die for sure. If you choose drug D, there's a 1/3 chance that no one infected will die, and a 2/3 chance that 600 million infected people will die. Which drug do you choose in this case? I bet you probably went with drug D. After all, a chance that no one will die seems like a pretty good bet. If you picked drug A in the first scenario and drug D in the second, you're not alone. When behavioral economists Danny Kahneman and Amos Tversky gave these scenarios to college students, 72% of people said that drug A was better than B, and 78% of people said that drug D was better than C. But let's take a slightly different look at both sets of outcomes. In fact, let's depict both choices in terms of the number of people who will live and die. Here's your first choice. Drug A will save 200 million people for sure, and for drug B, there's a 1/3 chance that all 600 million infected people will be saved, and a 2/3 chance that no one infected will be saved. And now let's do the same thing for drugs C and D. Surprisingly, you can now see that the two options are identical. Drugs A and C will save 200 million people, while 400 million people are certain to die. And with both drug B and drug D, you have a 1/3 chance of saving all 600 million people and a 2/3 chance of saving no one. We can argue about whether it's better to save 200 million people for sure, or to take a 1/3 chance of saving all of them, but one thing should be clear from the example. It's pretty weird for you to prefer drug A over B at the same time as you prefer drug D over C. After all, they're exactly the same drugs, with slightly different labels. Why does a simple change in wording change our judgments about exactly the same options? Kahneman and Tversky figured out that this strange effect results from two classic biases that affect human choice, biases known as reference dependence and loss aversion. Reference dependence just refers to the fact that we think about our decisions not in terms of absolutes, but relative to some status quo or baseline. This is why when you find a dollar on the ground, you don't think about that dollar as part of your entire net worth. Instead, you think in terms of the change that the dollar made to your status quo. You think, hey, I'm $1 richer. Because of reference dependence, you don't think of the options presented earlier in terms of the absolute number of lives saved. Instead, you frame each choice relative to some status quo. And that's why the wording matters. The first scenario is described in terms of the number of lives saved. That's your reference point. You're thinking in terms of how many additional lives you can save. And in the second, you think relative to how many less lives you can lose. And that second part, worrying about losing lives, leads to the second bias that's affecting your choices, loss aversion. Loss aversion is our reluctance to make choices that lead to losses. We don't like losing stuff, whether it's money or lives or even candy. We have an instinct to avoid potential losses at all costs. Economists have found that loss aversion causes us to do a bunch of irrational stuff. Loss aversion causes people to hold on to property that's losing in value in the housing market just because they don't want to sell their assets at a loss. Loss aversion also leads people to invest more poorly. We even avoid risky stocks that overall will do well because we're afraid of a small probability of losses. Loss aversion causes us to latch onto the fact that drugs C and D involve losing lives. Our aversion to any potential losses causes us to avoid drug C and to go with drug D, which has the chance of not losing anyone. Our loss aversion isn't as activated when we hear about drugs A and B. Both of them involve saving people, so why not go with the safe option, drug A over drug B? Merely describing the outcomes differently changes which scenarios we find more aversive. If losses are mentioned, we want to reduce them as much as possible. So much so that we take on a bit more risk than we'd usually like. So describing a decision one way as opposed to another can cause us to make a completely different choice. Even in a life or death decision like this, we're at the mercy of how our minds interpret information. And how our minds interpret information is at the mercy of our cognitive biases. My name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about mental accounting. This lecture is part of a series on cognitive biases. Imagine that you decide to go see a new movie that's opening up in your town. You head to the counter and hand the cashier a $20 bill. She gives you back a $10 bill and a $10 ticket. But when you get to the theater door, you realize you don't know where your ticket is. It's not in your purse or your pocket. It's just lost. What would you do? Do you think you'd pay $10 for a new ticket, or would you just head home? If you're like most people, you might be tempted to head home. In fact, when the psychologists Kahneman and Tversky presented this problem to college students, 54% of people said they'd probably just head back home. But now imagine a different scenario. This time, you decide to see the movie, and you head to the counter and hand the cashier $20. This time, she gives you back two $10 bills so that you can easily pay $10 at the door to get in. But when you get to the door, you realize that you can only find one of the $10 bills. The other one's not in your purse or your pocket, it's just lost. What would you do? Would you pay $10 for the movie or just head home? If you're like most people, you'd probably still go see the movie. In fact, when Kahneman and Tversky presented this problem to college students, 88% of people said they'd probably go to the movie anyway. The different responses to these cases illustrate a bias known as mental accounting. We use different accounts in our heads for different activities, and the resources from one account aren't automatically transferred for use in another. This is why we pretty rarely take $50 from our 401k account to have a nice meal, or why we sometimes blow our tax return on stuff we'd never blow our savings on. In our head, we automatically set up different accounts for different stuff, and if we end up with extra money we didn't expect, say from a windfall in a tax return, or even from an unexpected coupon, we end up blowing that money in this new extra account. It's why gamblers gamble a lot more when they're playing with house money. We use different mental accounts all the time, from the money we plan to spend on something fun like movies and plays, to the accounts we keep for our kids' college tuition. Our minds just naturally keep things separate. The problem is that our intuition to keep things separate violates a classic economic principle, the idea that money should be fungible. Classical economists are often puzzled by the fact that we can't just think of money as, well, money. Why shouldn't a $10 ticket and a $10 bill be the same thing? To an economist it should be, but for our minds, not so much. The good news is that we can use these funny mental accounts to our advantage. A friend of the behavioral economist Dick Thaler did just this. He set up a new account with money that he planned to donate to charity at the end of every year. Each time something bad happened, a parking ticket or a lost $10 for a movie, he took the money out of that account instead. His mental accounting caused him to think that the money wasn't really his anyway, and it made him feel less bad whenever he experienced losses. Our biases toward mental accounting mean that our minds don't work in the way that classical economists like to think, but we can use these mental accounting biases to our advantage. We have control over which accounts we set up and which we deduct from. Just be sure to remember that the next time you happen to lose your movie ticket. My name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about peak end effects. This lecture is part of a series on cognitive biases. I want you to think back to the last time you went to a restaurant and had an expensive meal. Now remember all the different parts of that event. Done? Well, then I want you to answer a very simple question. How was it? No matter whether you said it was just so-so or the best meal ever, I bet you experienced the act of answering this question as relatively simple. Deciding whether some event was good or bad is something we find pretty easy. We can quickly say whether we liked a particular movie, or how much fun we had on vacation, or even how our last job interview went. But making this kind of judgment should involve some pretty complicated computations. To judge how your last restaurant meal was, you might have to computationally combine how you rated a whole bunch of different points in the experience, and you have to judge how each of them fits together and come up with an overall rating. You also have to decide how many time points you're going to sample to figure out your rating. When you thought about the restaurant, did your mind give you a rating to the experience across every single minute, or every second, or even every millisecond? It turns out that our minds figure out this complicated problem by using a surprisingly streamlined strategy. In fact, when we remember an event, we tend to ignore lots and lots of the parts of that event. In fact, we seem to make an evaluation based on only two parts of our experience. The peak, that is the part of the experience that's most extreme, either good or bad, and the end, that is how it ended. All of our memories, both good ones and bad ones, are often remembered as such because of the action of these 2 points. To study this effect, the psychologist Danny Kahneman and his colleagues presented participants with a painful event. They had to stick their hand in really, really cold 14-degree water for 60 seconds. After that, the subjects were given a second event. It started out exactly the same as the first. Their hands were placed in really, really cold 14-degree water for 60 seconds. But then this second painful event continued. Participants kept their hand in the water for 30 more seconds, as the temperature was increased to a still painful but not as painful 15 degrees. Kahneman and colleagues then asked participants which event they liked better and which they would prefer to experience again. Surprisingly, participants overwhelmingly preferred the second event. Even though they were in pain for longer, the second event ended a bit better. And when you average the peak and end point of each event, the second one is better, even though it involves overall more pain. Kahneman and colleagues wondered whether the same peak end effect would work for people's memories in situations that we experience in the real world. They teamed up with doctors who were giving patients a painful medical procedure. Usually the procedure went like this. It started out as not so painful and gradually got more and more painful, ending at a moment of maximum pain. Kahneman and his colleagues thought that this procedure would be remembered as particularly awful, not because it was a painful procedure, but because the peak and end point of this procedure were particularly bad. To test this assumption, Kahneman and his colleagues ran a clinical trial. They extended the length of the painful procedure so it worked like this. Patients had to be in pain for overall longer, but the procedure ended on a slightly less painful note. Kahneman and colleagues found that people reported liking the second procedure much better. They reported not feeling as much pain and were even willing to come back for more repeated procedures. Kahneman and colleagues' clinical trial highlights one of the most surprising things about our peak end heuristic, namely the information that it doesn't take into account. And that's how long the event happens to be. Patients would rather be in pain for twice as long as the average of the peak and end is more pleasant. Since our minds only take into account the peak and the end when remembering an event, there's no way to tell how long a particular event was. We just kind of ignore that part of the event in our evaluations. This phenomenon is known as duration neglect. Our duration neglect means that wonderful experiences can stay just as wonderful even when you keep them really short. It also means that you can make somewhat annoying experiences longer, and you won't even remember them that way. The peak end effect also gives us some hints about how to make an event especially awesome. Since each event's goodness involves only its peak and its end point, we can make events particularly fun by making them end at their best point possible. In fact, lots of the events that we enjoy most involve ends that are also peaks. From the final winning goal to firework finales, saving the best for last seems to make an event better. So next time you're having a really nice meal, be sure to save some room for dessert. Hi, my name is Laurie Santos. I teach psychology at Yale University, and today I want to talk to you about the G.I. Joe fallacy. This lecture is in the series on cognitive biases. If you've watched a bunch of these videos, you've probably gotten a bit better at noticing your biases at work, and knowing that you might fall prey to them. You might also think that knowing about your biases would, naturally, make you less susceptible to them. Unfortunately, it's not always that simple. In fact, if you think knowing your biases is all you need to overcome them, then you'd be falling prey to yet another bias, the G.I. Joe fallacy. If you're a child of the 1980s, then you might have a guess about where the name from this bias comes from. Yes, it's from that cartoon known as G.I. Joe. Maybe you remember how these shows ended. Each episode had a sort of cheesy public service announcement that ended with the show's famous epithet, "Now you know, and knowing is half the battle." The problem with this idea, the idea that knowing is half the battle, is that cognitive science has shown us that merely knowing about our biases is often way less than half the battle. Now, there are certainly some cases where knowing is half the battle. Knowing your multiplication tables, for example, or knowing which aisle the milk is in. But there are many more where it's not the case, cases where just knowing something doesn't really help us all that much. For example, you may know that standing on the Grand Canyon skywalk is perfectly safe, but your mind will still feel like it's pretty scary. You may know that arbitrary anchors can mess up your final judgment, but you'll still feel like it's best to get 5 chocolates when you see a 5 for $5 sign. Finally, you may know that different wordings can affect your intuitions, but you still may be more hesitant to take a risk involving lives lost than lives saved. Years and years of research on cognitive biases has shown that knowing or recognizing yourself as having information is only a small part of what controls our behavior. In day-to-day situations, most of our behavioral control comes from other processes, like our habits or the situations we find ourselves in, and not from our conscious selves. This is why shaping our situations to nudge our behavior in the right direction, or even just learning to regulate your emotions, over time can be really powerful. The funniest part of the G.I. Joe fallacy is that even knowing about it, as the fallacy would predict, is less than half the battle. Even if you know that knowing is less than half the battle, you still have a tendency to think that what you consciously know is the main thing that controls your behavior. But it's not. Even if you've watched all of these videos, you're still going to be subject to the same effects that the videos describe. For most cognitive biases, including the G.I. Joe fallacy, knowing is not even half the battle. And so now you know, and that's less than half the battle.